Modeling of a simple ventilation model in Revit 2017. First of all, make sure that you have installed the Dan EDU localizer correctly on your PC. In Revit, go and start up a new project using System Template. Go to Level 1, Mechanical, and link the architect model into the project. Make sure the positioning is origin to origin. We see that the architect model is toned down, it's grayed out, and that is because the discipline is set to mechanical. If we start up a 3D view, you'll see the same. You can see it over here. The discipline is mechanical. As soon as we change this into architecture, in the beginning I said that this is going to be a simple creation of a ventilation model. If we should have done this correct, first step would have been creating spaces. So if you would like to go deeper into this, check out spaces. As you can see, when I'm inserting a space here, we could apply different types of data from our building for the use in our ventilation model. Since this is a simple modeling of a ventilation system, I will not use spaces. So we would like to create a small ventilation system in this area. We have some changing rooms, and this is a technician room. So first of all, I will go and create some sections in the building for creating a better overview of what we're doing. So I will create 2 new sections here. And they look like this. Remember, it's a good idea to apply view templates, and in this template file, as you can see, there are already made some view templates. Now we can see the levels, and I will do that on my section 2 as well. Apply the view template mechanical section. Instead of using these levels from this project, I could have used the levels from my architect model using this one, copy monitor. Again, if you would like to get deeper into this, take a look at copy monitor. This is where we reuse the levels already made from the architect. So I will use this in this project. Note also that we have a compound ceiling here in these rooms that we are going to work in. And if we opened over here the ceiling plan from level 1, we can see that the architect have already thought about a design in the ceiling. That means that we can place our air terminals according to this ceiling layout. So what we will do now for creating our ventilation system is that we would like to place some air terminals. And we would like to load some new air terminals. So I press Load Family. Not from the Dan EDU content. I will go one step back and go into Denmark catalog, pre-installed with Revit, into Mechanical, MEP, Airside Components, and air terminals. Here we would like to load both this one and this one. When holding the control key, I can select both and say open. So let's see, we will place an air terminal. We can take this one 600 times 600 with a 150 neck. If I place this one now, it will be on level 1 and the offset 0. That means it will be placed on top of the floor. So let's try to go to the section and see what is the distance from the floor to my compound ceiling. It's 2600. So back to the ceiling plan, level 1, and here I press 2600, and this is supply air, so I would like to place the supply air here and here, and of course I will not place it in the intersection of my ceiling, so I will move this 300 in this direction and 300 in this direction, so it will fit perfectly with my ceiling. I think we will try and move it a bit like this, and of course I can then begin to copy this into, for example, the next room here, like this, and this one I will move it like that. So let's see in our 3D model how it looks. As you can see, the architect model will behave a bit transparent, so I can see through. I can go to my section and see if my air terminals are placed correct, and it seems that they are placed correct in the compound ceiling. So on top of this ceiling we would like to place our ducts. Back to the 3D view, because I would like to see the specification of these air terminals before I begin to do something with them. Here you can see the flow is set to 235 liter per second. I'll change this to 60 or 50. Back to level 1, and then I will select these 4 air terminals, and that makes it possible to create a duct system. It will automatically detect that this is supply air because our air terminals are supply air. I can give it a name. I think this is okay. Since they are a part of this group, I can begin to generate a layout using this. I will not go deeper into placing the correct equipment in this technician room, but I can place a base, and then we can find out afterwards what specific mechanical equipment that we should use. So I'll place this here, and it will come up with a solution like this. If I'm not happy about that, I can select this one up here, solution, and I can go through the different types of solution. This is actually what I have thought about from the beginning. Into settings, we have the main duct and the branches. Right now it suggests a rectangular duct, but I would like to have a round duct. The the offset from the level is 3000, and of course I would like to have some round ducts as well, and with the offset of 3000. Finish layout, and it gives me a warning. Let's see what that can be about. Let's try to see this in 3D. It has something to do with the connection. In Analyze, I can add this one, show disconnects on pipes and ducts, to see if something is wrong, and yeah, this is what I thought, that this is not correct. Let's say that this is correct. Now we have an open end in the duct, so I can select the duct and say cap opening. So if I move my mouse over one duct here and press tab key a few times, you can see the whole system will be highlighted, and then I can left click to select the whole system. Then we can go into this one, duct pipe sizing. As you can see, we could change the velocity of the airflow. Let's try to see what happens if we set this to 8. Hopefully the ducts will become smaller then, because we will allow some higher velocity. Then you can see the branches will become smaller, and so will the main branch. We can then go over this system inspector and see, when I move my mouse over one of the branches, the flow is 50 liters per second. It's the same with this one. Hopefully when I move my mouse over here, it will become 100, and so on, 200, until it finished in the technician room. So that was an example on how to automatically create a ventilation system. If we should do this more or less manually, let's go back to ceiling plan. For example, I would like to create a new duct in here. So I go into system and say duct. This is a huge one. This is 800 diameter, and let's say 6 meters above floor level. So I will create a new pipe here. As you can see, it's above our view range, but we will fix that in a while. Until here and here, we're still in 6 meters above level 1. And if we would like to go vertically down now, we can say that we would like to end this 710 millimeters above level 1. So I change the offset and say apply. Then you can see we have a section of the duct here. Let's take a look at that in 3D, and it will look like this. Escape to cancel it. If we select the duct fittings, this round elbow, you can see that it will automatically select a specific elbow. We can make this smaller or bigger according to what you prefer. If we would like to split this one, we can select the duct and then go into this one. We can say split. We can say that this one should be even bigger, like this. Again, we have a warning here saying that this end is open, so cap open ends. Press tab a few times. When I model this duct, it will automatically have its own duct system, and this is exhaust air. One final thing that I would like to show to you is that in Revit it's possible to create an interference check if you have, for example, a construction model, or in this case a architect model, and you would like to see if this will interfere with some of the main constructions. You can run an interference check in Revit. So I will go and save this as a project, because now I would like to link this ventilation model back to my architect model. Close all the views, and then we can open the architect model, and if we go to the ground floor plan, we will create a ventilation drawing. So I create a duplicate, and I will rename this ventilation ground floor plan. Then I will link the model from before, this one. Again, remember, positioning is pretty important. Again, what we talked about before was this discipline thing. Since this is a mechanical drawing, this is a drawing concerning ventilation, the discipline should not be architectural but mechanical. And then we see the pipes, but the building will disappear. We'll take care of that afterwards. The ducts is only one line, and that is because this is set to coarse. So if we say, we can say medium, or we can say fine, doesn't really matter. And then we see the total thickness of our ducts. So let's see if we can recall our architect model. Underlay could be ground floor terrain, and we are looking up like this. We can see the ceiling layout here, and now we can also see the walls. But again, the architect model is toned down in a gray color, so the ventilation will be very clear in this view. If this ventilation model have contained more than this system, all of the ducts would have been black, and creating a documentation drawing to separate what is supply air, what is exhaust air. For this I will create a filter, because as you can see, when I move my mouse over this duct and press tab, I can select the individual parts of my ventilation model. Over here we can see that the system classification and system type is supply air, and that information I can use when I begin to create a filter. So when nothing is selected in my view, I go into visibility graphics, and under filter I will create a new filter. and it should be on ducts and duct fittings, and the rule should filter on system classification and supplier. So you type in supplier here and press OK, and I will add this filter, and the override should be done so that the lines are black and the pattern, these are not the new according to the BIP's drawing standards, VVS2. Maybe we should give it another line weight. Let's try with 5. And maybe we don't want to see the middle line in these ducts, so again into visibility graphics, under ducts, we don't want to see the center line, and the same with ducts fittings, like this. Thank you for viewing this video. I hope this have given you some inspiration on creating your own ventilation models.